Thanks for the invite, Daniel, and thanks to all of you for choosing to come here instead of having an after-lunch siesta. Or maybe you're going to have your siesta here, who knows. But either way, thanks for being here. So I'll get straight into it. This talk is about kind of the, I guess, the promise of microservices versus the reality. I mean, I think the reason we choose to build systems in this way is fundamentally about being able to work in a sort of decoupled and independent way for teams to be able to kind of build and ship things and add value to their business in a way that's not highly dependent on other people in their organization or outside of it. And I suspect that a lot of those of us that have done this for a while realize that the reality of this doesn't always measure up. That we often find ourselves in situations where we're in a sort of heavily interconnected environment, you know, that dependencies still exist, couplings still exist. And the result of this in terms of the sort of engineering experience and engineering productivity, you know, the impact on engineering productivity is that we're not doing a lot of the things we want to be doing. We're fighting broken environments. We're fighting with data not being correct in the environments we're working in. We're waiting for people to ship new API features that we need before we can move forward. And this sort of plethora of problems that leads to things moving slowly and everyone feeling kind of frustrated and not enjoying themselves very much. What I'm going to try and convince you of in this talk is that using API mocking or API simulation, I'll get into the naming stuff in a bit, can help solve these problems, even when used at kind of the sort of large scale, in the large scale microservices systems that we build nowadays, but requires some additional kind of supporting techniques and thinking in order to make it work well. So quickly about me, I've spent lots of years building software. It's often been in enterprise environments where there are lots of integration problems to solve. I've found myself wrangling with APIs and fighting with them in some cases a lot of the time. And for a number of years, I've been working on this open source project called WireMock, which is an API mocking tool, as you might expect. And I'm also the co-founder of a company building a cloud product on top of WireMock. I'm not going to talk about that today, but you know, suffice to say that the things I'm talking about in this are things that we're actively researching and building and that we're interested in. But today I'm going to mainly talk about the sort of tools and the techniques kind of in the abstract. And when I do refer to tools including WireMock, they're all going to be kind of open source things you can go and play around with easily yourself. So with that, I was tempted to call this slide coping strategies rather than decoupling strategies, but the problem we have when building these systems fundamentally stem from being coupled to other bits of the system, you know, via APIs usually. And since these are our sources of pain, there are a number of strategies that I've seen organizations use in order to try and kind of mitigate this in various ways. And it's not always a true decoupling strategy, but I'm going to go through a few of these first before sort of getting into the kind of mocking part of the conversation. So one is what I refer to as kind of process and gatekeeping. I think this is definitely a coping strategy rather than a sort of genuine decoupling strategy, but it's really where maybe you've taken your kind of old world sort of environment management approach and kind of grafted into a microservices environment. So this is where you have a small number of fixed environments that are shared by a lot of people. They're very heavily contended, and everyone's breaking them all the time, doing things to them, and so you kind of do this with them. You put a load of process and you know, human beings kind of in front of them, and you control very strictly what can be deployed, what data can be put in there, who can use them at a given moment, and all that kind of thing. And WireMock was kind of born into this environment. So I was in a team where we were in a very big sort of, it was kind of a digital transformation and it was kind of microservices, but it was sort of before either of those two terms existed, but it was basically that. Our product needed to talk to lots of different APIs that were being built by different bits of the organization and other vendors and all that kind of thing. And it was a mess. Nobody really knew how to do this stuff, particularly back then. And we were constantly fighting with all the things that I talked about. So environments not working, APIs being shipped that didn't conform to spec, you know, waiting weeks to get the right data in there, all that kind of stuff. And the sort of powers that be on this project kind of implemented this very strict regime, partly with automation and partly with human gatekeepers, to try and sort of mitigate the bad quality. And this slowed everything down to a crawl. It was incredibly frustrating. And the irony was that it didn't actually produce the outcome desired. It persuaded everybody to kind of game the system and to try and get things through this kind of labyrinthine CD pipeline and into an environment, rather than really sort of focusing on fundamental quality. So it didn't even work. So I suppose a sort of a slight evolution on this approach that I've seen a lot of organisations take is let's build lots of environments. If we give everybody, every team their own environment, which is a sort of full replica of production, then they can do what they like with it. They can put their own data in it, they can deploy code to it, they can switch it off and on again, whatever. It doesn't affect everybody else. So then the gatekeeping goes away. But then you have these problems of, quite obviously sort of operational cost. So I've spoken to a number of organisations who are paying more in the aggregate for their dev and test environments than they are to run their production environment. They have literally dozens of these things throughout the organisation. And it's operationally complex. You've still got to have a platform that can support these things, and sort of sysadmins and platform engineers end up having a lot more work to do in these kinds of environments. And it's also, there's a kind of cognitive overload kind of element to it as well. If you're running an environment and you've deployed everybody else's services into it just so you can get your work done, you have to know a lot about how those services work. You have to know about their implementation details as well as their interfaces. If you want to get data into them, if you want to fix them when they fall over, deploy new versions, all of this kind of stuff. So it takes you kind of a long way out of your own work when you're figuring out how to do this stuff. So again, not ideal. So then there's a kind of, I guess, a further evolution on this approach of sort of using fully integrated environments, which I'm kind of calling it smart environments. This isn't the term of art, I don't think, but I'm using it as a bit of a catch-all for a number of things. So there's a newer kind of class of products that help with this, where you can build and destroy ephemeral environments very quickly from configuration. And there's also this kind of remocal strategy. So Daniel is really the expert on this if you want to find out more. But this is about kind of composing environments from bits of stuff running locally, close to you, and some of it shared, and kind of composing the two together so that you don't create kind of full-scale replicas for everything. And this is, for hopefully fairly obvious reasons, an improvement on the produce a full environment for everybody strategy. But it's limited in its scope of applicability, I guess you could say. I think if you're a tech unicorn or if you're a scale-up and you have little to no legacy, then this can be very effective. But I think chances are most of us doing microservices are doing so in an environment that's kind of in the middle of a digital transformation that probably has several layers of legacy tech, where the microservices bit is only one part of the puzzle. I think even in modern environments, you increasingly have lots and lots of third-party integrations. There are certain types of sort of industry vertical where there's really heavy kind of third-party integration as well, which isn't going away. And this kind of strategy doesn't really help you in that kind of situation. So good for certain types of problem, but not so much for others. So then that brings us to this thing, so mocking or simulation or virtualization. So to be clear here, I'm not talking about the kind of in-code object mocking, the kind of Mockito type thing. I'm talking about simulating an API on the network. So your app that you're testing is still talking over the network to it, but it's talking to a simulation rather than the real thing. Out of curiosity, how many of you are using or have used this type of mocking that I've just described? Oh, great. Okay, that's good. And I suppose, how many of you have used it in a where you've kind of deployed this stuff into your environment and used it that way? So used it beyond just the kind of narrow integration testing or unit-like testing kind of thing? Okay, not so many. Doing this can help with this problem a lot. So by mocking, you can build kind of self-contained environments of the things that you're testing. You can do it a lot more cheaply than kind of running copies of everything else. You can mock legacy APIs. You can mock third-party APIs. You're not restricted in that way. And also the sort of cognitive load problem I talked about, whereby the point at which your understanding has to extend in order to get things done. With this, you kind of bring it in to understand the contracts at your boundary, but not having to go any further than that. So it's helpful in that way as well. But it's definitely not a free lunch. There's a lot of there are things you need to do, work you need to do in order to make this work well at kind of large scale. So this is really what this talk is going to be about. So let's get into that a bit. I mean, these are really the sort of main kind of objections or challenges that people kind of bring up regularly when you suggest the idea of doing kind of mocking at scale like this. Excuse me. The first one is, mocks aren't realistic enough. They're simplistic. They don't emulate the behavior of the real system. And so I test things with mocks. My builds are green. Everything looks good. And then I go to production. And something goes wrong that is revealed, through a real integration. So my response to that is that it's possible to get to a high degree of realism with current mocking tools if you know how to use them, if you use them in the right way, and you can observe behavior of real systems, and you can kind of port that behavior back into your simulations very effectively if you choose to use the mocking tools this way. The second point is just the effort involved in creating and maintaining mocks. If you're doing it the old-fashioned way, if you're hand coding all of your mocks, taking API designs and turning them into code, and you're having to do this, every team is doing this for every API that they're building, then this can be pretty labor intensive, and it's the kind of work that nobody really wants to do over the long term. It's sort of fun when you first discover the tool, and then it turns into this kind of miserable toil after that. What I'm going to talk about sort of in this talk really is techniques for kind of reducing that labor and that toil down to at least a manageable level, so that you can work with significant amounts of this stuff over the long term without it turning into this grind. And kind of related to that, so mock APIs drift away from their real counterparts over time is another concern. People tend to build mocks and really sort of focus on how they work sort of at the point in time that they need them, and then neglect them after that. And it's partly a maintenance work issue like the previous point, but there's also kind of a communication element. How do you know when the thing that you're mocking has changed? How do you know whether it's changed in a way that you actually care about, or whether it's kind of incidental? It's not always all that easy to do that. So these are all real problems. I mean, again, I'm going to talk about some techniques for how we work around that problem. So these are all surmountable problems. So what I'm trying to say is don't throw the baby out with the bathwater. So I just want to introduce some sort of high-level concepts at first to set some context before getting into kind of tools and workflows. So I want you to think of these kind of three artifacts, I suppose, that we're going to compose together in order to get our work done. So there's I'm going to call this an observation. So essentially this is a piece of captured traffic or a captured observation of an interaction between a client and an API. So for a REST API, it would be an HTTP request and response. And then we've got a simulation, so based on a tool like WireMock. I'm going to use WireMock as the exemplar, but there's dozens of open source tools that will also do this. Simulations are behavioral, so they're kind of actually expressing behavior rather than merely sort of structure. But then you've got contracts, which are the kind of the detailed, the most complete view of structure, I guess. They're the kind of syntactic description of an API, what its operations are, what the constraints are around its, how its data looks, what the constraints are around its use, all of that kind of thing. But it's not behavioral. This is a kind of important characteristic of contracts. So there's a few useful things we can do when we combine these things together. We can take observations and generate simulations. We kind of typically call this recording. We can take contracts, we can take an OpenAPI and generate a simulation as well. And we can validate, we can contract test. And essentially this means taking observations and checking that they conform with the contract. And we can take observations of traffic to and from a real API or from a simulated API. So we can validate both for conformance with the contract and kind of tie everything together that way. There's a key point to note about this, something that I sort of keep, I suppose, tripping over more and more doing this kind of stuff. All of these kind of aspects, it's a bit like looking at system architecture, where you can't tell the full story in one artifact. You know, you sort of have a bunch of different artifacts that are all telling kind of useful perspectives on the architecture, I guess. And it's kind of similar with this. The OpenAPI will tell you things about data structure and format and so on like that you won't find anywhere else. But then the simulation will give you behavioral information, business rules and functional rules around how the API works that the contract won't. So a good example of this would be something like rate limiting. So you can put in the contract information about the headers that you'll receive and the fact you'll get a 429 response if you exceed the rate limit. But what you can't express is what is the actual rate limit? What behavior would I have to engage in order to trigger this? So there's, like I say, syntactic information, but not behavioral information. And there's a whole plethora of other stuff like this that is only partially expressed. There are also things that are just not really expressed at all. You know, things that you can only really know by looking at the code or looking at the internals of the system. Some of these things we can kind of make guesses about from sets of observations, but they then just become educated guesses rather than certainties. The consequence of this is that when you're converting between things, you have to bear in mind that what you're getting isn't sort of complete. You can take an OpenAPI and generate a simulation from it, and you'll get something which is syntactically correct and really useful as a baseline. It's a huge labor saving to do this, but it probably won't be sufficient for the things that you need to achieve in terms of development and testing. You nearly always need to take this and start expressing kind of the nuances of behavior that you care about, that you depend on, in order to meaningfully test your system. And I think there are lots of tools that will do this sort of thing, that will do very, these very convenient sort of translations, particularly from OpenAPI to a mock. And I think maybe where some of the reputation for sort of being oversimplistic for these tools comes from doing this kind of thing. That essentially I'm getting the same canned response every time when I test things against this, and this isn't sufficient. So that's something to bear in mind. So now that we looked at the concepts, I'm just going to sort of talk a bit more about the tools that kind of implement these at a high level. So let's address this thing about naming, first of all. So I think of mocking, simulation, and virtualization as fundamentally the same concept. I know there are some people out there that will tell you these things are different, but fundamentally they're doing the same thing. It's mimicry of an API to some sort of along some spectrum of realism. And I think people tend to think of sort of mocking as the things more towards the left, the sort of simple, canned, very localized responses that we set up, and then things like service virtualization and simulation are more to the right of the spectrum, where you're investing more effort in the simulation in order to make it more realistic. But fundamentally, it's all a single concept, and I tend to use these terms fairly interchangeably nowadays. So next up is kind of API observability. So this is not the kind of sort of observability that Honeycomb have popularized. This is really just the ability to go and make observations of API interactions. We can do this kind of passively, so we can kind of just pull things off the network in an environment as things are happening, or we can do it actively, where we kind of intentionally generate interactions of the kind that we need, so that we can go and then capture that traffic and look at how it played out. There's a bunch of different ways we can do this. Excuse me. We can do this in code. We can kind of instrument code directly and avoid the network altogether, which is really it tends to be a kind of active mode of doing things. You can do this inside a test runner while we're running a bunch of integration tests. There's proxying. This is probably the most common way that you see for doing it. So forward and reverse proxying, MITM proxying when there's TLS, when there's HTTPS involved, which is kind of painful because you're essentially sort of breaking HTTPS security in order to kind of get in the middle of what should be an encrypted connection and reading it. But it is possible to do, and there's fairly widespread tools for this. Then there's PCAP, so packet capture, which is not in such widespread use. Again, this is kind of unwieldy to use with encrypted data. So tools like TCP dump and Wireshark are good for this, but not so good if you've got encrypted data, so that doesn't tend to happen so much. And then there's these two kind of new kids on the block, relatively speaking, which are interesting solutions for this, emerging solutions, I would say. So there's eBPF-based tools. So eBPF allows you to kind of deploy code in a controlled way into the network stack in a process running in your environment, and then you can kind of pull things out of it. And crucially, you can do this kind of beneath the encryption layer. So it's a neat solution for problems of otherwise having to kind of break security mechanisms in order to observe traffic. Similarly with service mesh, so service mesh kind of routing layers that sit sort of on top of the network and pass traffic around can also be made to take copies of events that happen on that in the mesh and put them somewhere so we can use them. And then finally, there's contract testing, and I'm sort of defining this, like I said before, in this case as taking observations and checking their validity against the contract. And the observations can be of traffic to a real API or traffic to a simulated API, doesn't matter. There's a variation on how you can do this actually, which is using kind of generation to generate snapshots at different points in time of a contract and then diffing the contracts and then applying a bunch of rules saying if certain types of difference appear, then this is a breaking change or this is a significant change. This is fundamentally what it is. For clarity, I know a lot of people tend to think of contract testing as being sort of synonymous with consumer-driven contracts, so tools like Pact or Spring Cloud Contract. That's not what this is. I actually canvassed a few people in that community that I knew to say are people using these tools in this way to validate mocks, and I've got a pretty uniform, no, they don't. So it's not that. And finally, there's this. I mean, I think it's technically illegal now to speak about software in any way without mentioning AI in the conversation. So I'll address the large mammal in the corner of the room. In the sort of experimentation that we're doing around using AI for this stuff, there's actually some, I think, serious opportunities for it being used as a productivity lever. LLMs are quite good at generating sort of open formats, so OpenAPI being an obvious one. There's a ton of that around the internet and therefore in the training data. WireMock's sort of open source, the JSON format for it has also been around for a long time, and LLMs are fairly proficient at generating that on demand as well. What I've found this is particularly good for is this problem of when you've generated a baseline mock or simulation, and you now need to do that kind of enhancement to get from that baseline to start asking for specific data variations, behavioral variations, all that kind of thing. Then you can get LLMs to do that kind of thing fairly effectively. You kind of say, here's an example, a pre-generated example of what this looks like, vary it for me in this way. And an important thing is that if you're kind of building the plumbing for contract testing already, then this can serve as a guardrail. So when your AI coding assistant goes off piste and generates something weird, you can kind of put it into this loop where you say, go and check this against my contract, and if it's wrong, respond to the feedback, sort of fix the thing that wasn't right. So you can gain some confidence that you're not generating things which are subtly wrong when you're doing this, using the same contract testing techniques that we've just introduced. And yeah, I mean, obviously AI is pretty good at taking sets of observations and making educated guesses about them. So this is another thing which is quite labor intensive to do as a human being and quite well suited to LLMs. So let's talk about types of workflow. I think there's fundamentally kind of two situations you might find yourself in. One is where all of your API producers, or the APIs that you're integrating with as a consumer, are producing contracts that you can rely on, that are validated, or maybe they're generated directly from code or something like that. And they're publishing them somewhere reliably where you can go and find them. And this is a great place to be, because then you can kind of subscribe to those changes, and you can regenerate your own simulations from it. You can validate the interactions with your own simulations in your own tests against a contract provided by the producer. And this can be very labor saving and gives you a lot of confidence if you sort of trust what the producer is giving you. Last time I did this was for the company I was working for was integrating with a sort of third-party partner, and they were building a big complex API for this partnership, and they didn't really have a lot of experience doing this, and they didn't give us a sandbox to work against at all, so we kind of had to build a mock just to have something to test against. And they kept just emailing us kind of a Word document every 2 weeks. And that was the documentation, and needless to say, it wasn't complete, and it was quite often wrong as well. But we did persuade them to start exporting an OpenAPI doc automatically from their code. So whenever they did a new build, they used their sort of frameworks generation tool that would spit out an OpenAPI doc, and they would send that as well. So we plugged that into WireMock. There was a extension for WireMock someone at Atlassian had written at the time, which would validate the traffic, do the kind of in-code capture and validation of traffic. So we just kind of plugged that in there with the OpenAPI that they sent us, and that quickly revealed all of the discrepancies, let's say, between reality and what they'd sent us in this Word doc. So that kind of meant when we did finally deploy this product, the kind of alignment or the misalignment between reality and what we built was much less than it would have been if we trusted the Word doc alone. But unfortunately, most of us find ourselves in this situation. Most companies I speak to seem to be, they certainly don't do kind of open API institutionally. You have a few teams here and there doing it well, and then some doing it not so well. But as a consumer, you can't reliably get hold of a contract that you can really trust. So you have to generate it yourself. And this is perfectly doable. You can generate a contract representing just the part of the API or the parts of the API that you care about. And then you can otherwise use it in the same way I just described. You can use it to validate, interact. You can generate a simulation from the data or from the contract, and then you can ongoing use the refresh the contract and then use that to validate your simulation. So you can get that same confidence that way as well. And I'm just going to run through. I decided not to try and anger the demo gods today, so I've chickened out, and I'm not doing a live demo, but I'll give you something close, showing you kind of a somewhat sort of concrete example of how you put this together. And this is just it's a small project that I kind of put together. It's on GitHub, so you can go and look at it yourself. It's really just a sort of bag of NPM projects and shell scripts, but should illustrate the point nicely, I hope. So let's say we have this sort of fictitious payments API that we want to integrate our app with, and we want to build a mock, and we want to capture a contract that we can use to validate it. So we might use curl to make a test request, kind of proxied through these tools to this payments API, and then capture the results. So there's two tools in here. Obviously, WireMock I've introduced already, so that's capturing data and turning it into capturing observations and turning them into a simulation. And then there's this tool called Optic, which will capture observations and build contracts, build OpenAPI. So in our first step, we make this request and we build these artifacts initially, and then we've got stuff that we can work with, we can test against. So here's what that would actually look like. So pay close attention to that amount field, which, as you'll notice, is currently a number. So now some time has passed, and we suspect that the payments API has changed in some way. So we rerun our traffic, we rerun our curl requests, but this time we just run them through Optic, and Optic will capture a new version of the OpenAPI spec. And this is just recapturing, and you'll notice that now the amount field has changed to a string. I know you might think, why would anybody do this in a financial API? But it happens, believe it or not. But anyway, this has changed in a significant way. But we want to go and validate our simulation. So remember, our simulation was built from the previous run, and it's got that old version of that piece of data in there. So now we bring another tool in. So Prism is, amongst other things, is a proxy that will validate traffic against OpenAPI. So it will do the sort of contract testing part of the equation. So we now make our requests through Prism, but to our simulation this time, with the OpenAPI we've just generated in the previous step as an input, and that generates a validation report as output. And so we do this, and as we can see, we get this error message. and it tells us that, hey, you gave us the number, and the contract says it should be a string. Optionally, so I mentioned this sort of diffing thing earlier on. This is something else that we can do also with Optic, or there's a bunch of other tools that will do this now as well, where you can take the old and the new version of the OpenAPI, you can diff them, and it will give you this nice report where it will tell you the things that it thinks are significant changes or breaking changes. This is it kind of running in code. So hopefully fairly obviously you could run all this in CI quite easily. You could have scheduled jobs, or you could have some other kind of trigger that would kick all this stuff off, automate it, publish these reports on your CI servers, kind of report publishing place, wherever that is, and automate a lot of this process so that you are proactively kind of catching these problems as they happen, rather than finding out that actually the divergence between the mock and the real thing has happened, and you're only discovering it in staging or in production. So I've kind of shown what's possible with the sort of current state of the art, I guess, but I want to sort of look a little bit into the future as well. I think there are some things happening, evolutions of tools and so on, and standards and so on like that, that are going to make this easier and kind of expand the range of possibilities. So I'm going to talk a little bit about that now. One element of this is that I kind of mentioned before that there's still sort of a lot of white space in what we can really adequately describe about an API, at least using standard tools. There are lots of things that we can't say about an API using the tools at hand at the moment, and that we're forced to either guess at through observation or kind of go and dig around in the code in order to understand. But that situation is sort of changing, and two big contributions to that are these kind of sibling standards, which were both released last year by the OpenAPI standards team. The second one, overlay, so Lorna, who's over here, is chiefly responsible for that, so deserves probably a round of applause in her own right for all of our hard work on that. Sorry for putting you on the spot there. So Arazzo, the workflows standard, is a way of describing how you can achieve a kind of multi-step interaction across one or more APIs, and it describes things like sort of expressing kind of invariants while you're doing that, and also how to move data between calls. And I think this is going to be really interesting, particularly as the kind of tool support for this picks up, because it's describing information that we didn't previously have. So if you have a contract that also includes an Arazzo description, then there are sort of inferences you can make, or certainties even, about the behavior of the API that can map straight onto how we simulate it. So this should reduce some of the types of work that we have to do kind of either manually or with an AI tool in order to behaviorally enrich our mocks. Overlays, I think they are interesting. Overlays are a way of kind of deconstructing and recomposing OpenAPI documents. They tend to get very big anyway. There's a way that you can add these kind of vendor extensions on, so sort of non-standard properties to describe things that aren't in the standard. And these are very useful, again, for sort of filling in these bits of white space. So for instance, the rate limiting example I gave earlier, there are organizations that will add kind of non-standard rate limiting information in there that will tell you what the actual rate limiting parameters that will trigger a condition are. Excuse me. Overlays make it a lot easier to work with these without your OpenAPI description becoming completely unwieldy. And what I'm hoping, this is a bit more speculative, but I'm hoping that this will spur more innovation around kind of these small formats and standardizing on these as ways of describing things like rate limiting, pagination, and so on like that. So then I've already mentioned eBPF and service mesh. I think at the moment there's not a huge amount of integration between these types of tools, and I think you have to do the work yourself in order to kind of take observations from these tools and use them in a context like building simulations. They're not maybe as ubiquitous as I think they might be in a few years. I think it could be the case in a few years' time that this is just kind of part of the substrate on which we build things, and there will be a way of grabbing observations of, for instance, HTTP traffic in kind of any cluster you're working in. So this will lower the sort of cost and effort and hopefully sort of improve accessibility to observations of how APIs are behaving, and thus make everything else that we do with that easier. And then finally, there's, again, I think you can't move but for mentions of MCP at the moment. I think it's right at the peak of its hype cycle. But while, MCP, whether or not you think it's interesting in its own right as an API standard, the great thing about it is that there was just nothing before that, and now everybody has coalesced around the same way to integrate AI tools with everything else. And the effect of this is that it opens up all sorts of possibilities for tying your existing kind of AI-based coding workflows into new tools like API mocking tools. This is something we're experimenting a lot with at the moment, and the things you can accomplish, particularly in kind of building these kind of making these composite changes to projects, so changing the things that are using the API along with changing the simulation and making sure they all tie together, shows a lot of promise, let's say. So I think this is going to be another sort of major driver of productivity improvements. And that's kind of about it. So I'll leave you with these things, which I hope you'll take away and remember. Modern mocking tools can produce realistic simulations, realistic enough for, I would argue, most development and testing activities. By the way, I didn't mention this before. I'm not suggesting that you should throw away integrated testing altogether. This is always a vitally important part of your overall testing strategy. But it should be reserved for the things where there's actually genuine integration risk. And I think that's, if done well, that should be a sort of fairly small minority of the work. And the majority you can do without having to resort to doing that and make life a lot easier for yourself. So the combination of these techniques I've talked about, so API observability, generation, contract testing, are ways that you can reduce the labor involved in doing this stuff and increase your confidence in the results of it. And finally, using contract testing as a guardrail for Gen AI is a great way to work with it. And again, be able to get that kind of productivity gain with this sort of baseline of confidence and support that gives. And that's it. Thank you very much.
Thank you very much, Tom. Fantastic stuff. Any questions, folks? We've got about 10 minutes for questions. I appreciate you've got the after-lunch buzz going on. I'll start, Tom, by asking, I'll take Lorna for, was someone over there, or shall I come over?
Thank you so much for the talk. It was wonderful. You mentioned early on that a lot of people, the first time that they try some of these automated mocking tools, just find they get the same response back every time. What's your kind of first step advice for those people? Do they go straight to asking the LLMs to do better or adding more example responses? What's your first line defense?
I mean, I would usually say it's a good idea to try and understand something yourself before you ask an LLM to do it. I suspect, I hope most people would agree with that sort of vibing things, particularly if you're in a complex, distributed environment, is maybe not the best idea. I mean, what I've done a lot of when I've been working with these tools is to try and find ways of making observations of things happening either in production or in environments where things are integrated and working, and then trying to figure out from those observations, okay, what is this telling me? So if I make this date parameter in the future, I get a happy path response back, but if I make it in the past, that's not valid, so I get an error. If I change pagination parameters, then this is the impact on the output that I get. Or, this resource can go through a finite set of states. So, a payment might be sort of initiated and pending and in fraud check and then completed, and the data looks different in these states. So I think just taking observations of the thing happening and then sort of porting those observations back into your simulation is a good way to start. And you can do some of that by recording, so you can sort of get an approximation of it, and then some of it you can do by hand, and then, as I say, hopefully when you understand how to do it by hand, you can then ask an LLM to industrialize that for you.
Thanks.
Love it. Any other questions at all? Oh, we've got one behind there. That's all right.
Yeah, also thank you for the presentation. I just wanted to ask, in the scenario when you're building an API and you have this luxury of starting from the contract, how would you make sure that actually what needs to be in the contract, or rather, how would you make sure that there is a coherence between the contract and the contract tests, that they align, right? Because you may start with building the contract, but then you may need to make sure that even the fields that are present in the contract would be also present in the contract test, and at the same time not to repeat yourself, that because that doesn't make sense to repeat those things. So yeah, how would you approach that?
So that's a great question. I think one thing to clarify about the kind of contract testing I'm advocating for here is that it kind of happens as a byproduct of other types of testing. So this is another distinction between this and consumer-driven contracts, where you're kind of producing a specific artifact for those tests. When you put contract validation kind of into, in the front of an API simulation or a real API, you're running a bunch of other tests. You're running a bunch of functional tests, which, if you've built them correctly, will fail if pieces of data are missing, if the contract isn't right from the perspective of the caller. Does that make sense?
We had chat for offline as well. Fantastic question. Any more questions, folks? Oops. No step. My bad. Can I just ask, Tom, what's your thoughts on how LLMs will affect the end-to-end testing now? Because I'm just thinking, I've seen a bunch of folks saying like, oh, I can record the screen, what I'm doing, and verify off that, and that kind of holy grail, which I've been chasing for years, right? Do you think it will push more folks to do literally front-end testing and not test the APIs?
I mean, I think you see that happening a lot already. I mean, I think whenever there's a new generation of sort of front-end driven testing tools, you see this just proliferation of thousands of slow, brittle, kind of not so great tests being built with it. And I think this is going to be no exception. I think there's a plethora of tools out there already that will just kind of read your DOM and generate some tests and kind of encourage you to just spam them out there and not think about them too much. I think, there's there are some signs that there are some people taking this seriously as a problem and are looking at how LLMs can kind of help build test infrastructure, I guess you'd call it. So building the rudiments on which you build your test, whether it's page objects if you're going through a UI or means for interacting with APIs and being a little bit more intelligent about where the test is kind of going in and out, where mocks are used versus sort of real end-to-end testing. And providing that supporting infrastructure so then you can build good quality tests on top of that, rather than just kind of mindlessly generating the worst kind of tests.
Yeah, cheers, Tom. That's great. The great thinking points. Final question, if anyone's got a burning question. If not, one in the back then, I'll get that one if you like.
Thank you, mate. Thanks for the talk, super interesting. I was basically, because there's a bit of time left, and this might be a big question, I'm not sure, but I was wondering if you could go into a bit more detail about how these tools help with mocking like stateful behavior and things like that. And the context is that when I tend to mock these API behaviors, I feel like I'm recreating the API sometimes, and that's a feeling that I don't want to have. I don't want to feel like I'm having wasted effort there, basically. So I wondered if you could go into a bit more detail.
That's a really great question, and that's probably one of the less solved problems in this space at the moment, and one that we're very actively working on with WireMock Cloud at the moment. I know I said I wouldn't talk about it a lot, but yeah, that's a hard one. I mean, we're looking at ways that we can look at recordings, and again, it's this thing about kind of making inferences about behavior. And then sort of encoding it in the simulation. So we've done a little bit of work in this direction already, kind of looking at essentially a snapshot of an API and saying, well, this looks like a kind of stateful REST endpoint. This looks like this is the input data that kind of creates the state, and then we kind of infer that this is the state that actually gets constructed. So the input state usually plus a load of synthesized state that gets added to it. And then we build a stateful model around that. As I say, it's not a perfect approach in that it kind of assumes that this is a REST API kind of following CRUD, sort of typical CRUD conventions for a REST API. But I think there are, we're going to be actively examining how we can do this. How we can sort of reasonably confidently at least take observations and turn them into stateful behavior. And again, I think this is probably where the LLMs will ultimately end up helping, because that sort of inference can be a little bit more nuanced rather than sort of hard kind of rules-based kind of thing.
Fantastic. I think at that point, please join me in thanking Tom once again. Appreciate it, Tom. Thank you.